Unveiling ancient Babylonian techniques for quadratic equations. Ancient Babylonian mathematics stands as a cornerstone of early human intellectual achievement, particularly in the realm of quadratic equations. The Babylonians developed mathematical techniques that allowed them to solve complex problems, laying the groundwork for future advances in algebra, geometry, and calculus, and showing a sophisticated understanding of numerical relationships. Quadratic equations, which involve the solution of problems according to the formula ax2 plus bx plus c equals sine 0, where a, b, and c are constants, were fundamental in these ancient mathematical explorations. These equations describe a parabola when graphed and are crucial for solving various practical problems involving area and measurement. The origins of quadratic equations can be traced back to ancient Babylon, where these formulas were used extensively. Babylonian mathematicians utilized quadratic equations to address issues related to surveying land and constructing architectural structures, showcasing an early form of practical application of mathematical theories. In terms of representation, Babylonians had a unique numeral system based on the sexagesimal base 60 system, unlike the decimal base 10 system used today. This system, which also contributed to the modern division of hours into minutes and seconds, featured a place value notation that facilitated complex calculations and the solution of quadratic equations. The mathematical methods of the Babylonians differed significantly from modern techniques, primarily due to their numeral system and lack of a concept equivalent to zero. Their approach to solving quadratic equations involved a geometric method, where solutions were found by effectively completing the square, a method that has parallels in modern algebraic practices. The cuneiform tablets are our window into the mathematical prowess of the ancient Babylonians. These clay tablets, etched with wedge-shaped script, contain a wealth of mathematical data ranging from arithmetic to algebra, illustrating the sophisticated methods Babylonians used to solve quadratic equations. In ancient Babylon, architecture and astronomy were highly developed disciplines that relied on precise mathematical calculations. Quadratic equations played a crucial role in these fields, allowing for the design of monumental structures and the prediction of astronomical events, showcasing the practical applications of their complex mathematical concepts. Babylonians approached quadratic equations using specific methods that were remarkably advanced for their time. They employed techniques such as algebraic manipulation and geometric representation, which enabled them to solve problems systematically and efficiently, predating similar methods in other ancient civilizations. To demonstrate a Babylonian quadratic equation, historians often refer to problems documented on the tablets. For example, a common problem might involve finding the dimensions of a rectangle given its area and the difference between its length and width. Babylonians would solve this by manipulating the terms to form a recognizable equation. One notable Babylonian technique for solving quadratic equations was completing the square, a method still taught today. They would rearrange the equation until they could form a perfect square on one side, thus simplifying the solution process and finding the roots of the equation effectively and accurately. Babylonian mathematicians approached quadratic equations differently than modern algebra does. While today's methods involve symbolic algebra and formulas, Babylonians used a geometric approach, essentially manipulating areas to solve problems. This method, known as completing the square, was more visual and less abstract than current algebraic techniques. Accuracy was crucial in Babylonian mathematics, especially given their reliance on consistent and precise construction and astronomical calculations. They meticulously recorded their computational processes on clay tablets, ensuring their methods were verifiable and repeatable. This precision underscores the practical and administrative applications of their mathematical endeavors. Babylonians solved real-world problems using their mathematical methods, demonstrating the practical application of their quadratic solutions. For example, they might calculate the area needed for a temple's layout or manage agricultural plots, using geometric principles embedded in their approach to quadratic equations. In terms of tools, Babylonians used basic yet effective instruments for their mathematical work. They mainly employed clay tablets for recording and a stylus for inscribing cuneiform script, which included their numerals and computation signs. This simplicity belies the complexity of their mathematical concepts and calculations. The education system in ancient Babylon was quite advanced, with mathematics being a central subject taught to scribes. These scribes learned to solve quadratic equations among other mathematical techniques, which were vital for their roles in administration and trade. Their education not only included computation, but also problem-solving skills integral to Babylonian society. Key mathematicians of ancient Babylon made remarkable contributions that are foundational to modern mathematics. Figures like Nabu-Ramani and Kidinu advanced astronomical calculations, which indirectly influenced mathematical practices by requiring precise arithmetic to predict celestial events. The preservation of Babylonian mathematical texts primarily comes through clay tablets that have survived millennia. These cuneiform inscriptions provide a direct glimpse into the mathematical sophistication of ancient Babylon, showcasing complex algebraic and geometric calculations. Modern rediscovery of Babylonian mathematics has redefined our understanding of ancient math. Scholars have been particularly stunned by the Babylonians' use of a base 60 numerical system, which allowed them to perform calculations with a degree of accuracy astonishing for their time. Mathematical symbols used by the Babylonians were relatively straightforward yet effective. They employed a positional notation system, which is a precursor to the decimal system used today. This system facilitated the handling of large numbers, crucial for administrative and astronomical purposes. The role of quadratic equations in Babylonian economic transactions was significant. They used these equations to solve problems related to land division and property inheritance, showcasing an early form of algebra that was deeply integrated into their daily lives and economic practices. The role of quadratic equations in Babylonian economic transactions was pivotal. They used these equations to solve problems related to property division and trade. By calculating areas and volumes, Babylonians ensured fair trades and equitable property settlements, showcasing their advanced mathematical skills in everyday economic activities. Babylonian mathematical principles significantly influenced the development of early algebra. Their methods of solving quadratic equations laid foundational concepts that were later refined in Islamic mathematics. This early form of algebra was crucial for solving more complex equations and contributed greatly to mathematical theory and applications beyond Babylon. Exploring the accuracy of Babylonian solutions to quadratic equations reveals their remarkable precision. Despite the absence of modern tools and notation, their methods often produced exact solutions. This accuracy was essential not only for theoretical mathematics, but also for practical applications in surveying and construction. The limitations and challenges of the Babylonian approach to mathematics included their numeral system, which was less straightforward compared to today's decimal system. This complexity sometimes led to cumbersome calculations, limiting the scope of problems that could be tackled efficiently with their techniques. The legacy of Babylonian mathematics continues to influence contemporary math theory. Their early work in quadratic equations and algebra set the stage for later developments in mathematics. Their enduring methods and theories provide a historical context that enriches our understanding of the evolution of mathematical concepts. Babylonian mathematics, though ancient, has practical applications even in today's context. Their methods, particularly in quadratic equations, offer a unique perspective on problem solving that can enhance modern computational techniques. This integration of historical knowledge can lead to innovations in fields ranging from engineering to economics. Geometry played a crucial role in Babylonian solutions to quadratic problems. By incorporating geometric concepts into their calculations, Babylonians were able to visualize and solve complex equations. This method illustrates the interdisciplinary nature of ancient science and how it can inform current mathematical practices, especially in architectural and design fields. Comparing Babylonian methods to those of the Egyptians reveals distinct approaches to mathematics. While Babylonians developed a more algebraic and abstract method, Egyptians used a more practical and arithmetic-based approach. Understanding these differences enriches our appreciation of ancient mathematics and provides diverse methodologies for solving similar problems today. The influence of Babylonian mathematics extended beyond its own civilization and left a significant mark on Islamic scholars. These scholars preserved and expanded upon Babylonian techniques, which later played a vital role in the development of modern algebra. This historical connection underscores the long-lasting impact of Babylonian intellectual achievements. Astrology and divination were integral in shaping Babylonian mathematical practices, reflecting their belief in the interconnectedness of celestial and terrestrial phenomena. This perspective influenced their mathematical models and calculations, offering a fascinating glimpse into how ancient cultures interpreted the universe and its impact on daily life. Technological tools have revolutionized the way we understand ancient mathematical tablets. High-resolution imaging and 3D scanning allow scholars to examine inscriptions that are otherwise eroded by time, unveiling hidden details of the Babylonian numerical system and methods that were previously obscure. The educational value of studying ancient mathematical techniques extends beyond historical curiosity. By engaging with Babylonian mathematics, students and researchers gain insight into the evolution of mathematical thought and its practical applications, fostering a deeper appreciation for the discipline's universal and timeless nature. Interpreting ancient Babylonian mathematical texts poses significant challenges due to the fragmentary nature of the tablets and the complexity of the cuneiform script. Scholars often rely on cross-disciplinary approaches, combining archaeology, linguistics, and mathematics to piece together these ancient puzzles. Future research in Babylonian mathematics promises to further uncover the sophistication of these ancient scholars. Potential areas include deeper analysis of untranslated tablets and exploring the mathematical relationships between Babylonian techniques and those developed in other ancient cultures. Museums and academic institutions play a crucial role in preserving Babylonian mathematical heritage. By curating exhibits and facilitating academic research, these institutions ensure that the knowledge of Babylonian achievements in mathematics continues to inspire and educate future generations. Engaging young learners with ancient mathematics, especially from civilizations like Babylon, can spark a profound interest in both history and math. Interactive storytelling, puzzles based on Babylonian problems, and hands-on activities with replicas of cuneiform tablets can transform abstract concepts into tangible, exciting challenges. The intersection of mathematics, history, and archaeology in Babylonian studies offers a multidisciplinary approach that enriches our understanding of ancient societies. By studying how Babylonians solved quadratic equations, we gain insights not only into their mathematical prowess, but also into their societal structures and daily lives. Upcoming exhibitions and seminars on Babylonian mathematics provide invaluable opportunities for both academics and the public to explore this ancient discipline. These events often feature lectures, interactive workshops, and displays of authentic artifacts and replicas, making the complex world of Babylonian math accessible to all. For those interested in delving deeper into the world of Babylonian quadratic equations, numerous resources and books are available. These include academic texts that detail mathematical techniques and analyses of cuneiform tablets, as well as more accessible works that provide a broader cultural context. The enduring legacy of Babylonian mathematics is its relevance today, not just in the field of mathematics, but also in how we understand and interpret the capabilities and innovations of ancient civilizations. This legacy continues to influence educational methods and the development of mathematical thought around the world.